Hey guys, welcome back to our Chapter 11 practice test. Marching on, we've got problem number 3 here, and we're going to take a look at. This is another one of those chi-square goodness of fit tests. Maybe I shouldn't have said that, but that's what it is. And let's see, how does this work? The distribution of blood types varies from country to country. Actually, it doesn't vary all that much, but it does vary a tiny bit. So, in 2012, the Japanese Red Cross reported that 30% of Japanese people are type O, 40% are type A, 20% are type B, 10% are type AB. So, a certain Japanese talent agency publishes the blood types for its talent. An entertainment reporter thinks that the distribution of blood types differ from the typical distribution. And the reporter gathers a random sample of 51 artists from the agency's roster, finds that 18 of them are type O, 21 are type A, 9 of them are type B, and 3 are type AB. So what kind of test should we use to do this theory? So let's do the typical analysis here. How many samples did we take? Just one. How many variables are we looking at? Well, we just have one variable, blood type. Don't be fooled, blood type has 4 different categories, but it's still just one variable. So, one sample, one variable. This is the chi-square goodness of fit test. Next, we're going to write down the hypotheses. The null hypothesis is always that the expected blood type distribution is true, and for a little bit of context, we're going to say it's true for this agency, which means that the alternative hypothesis is going to be that the expected blood type distribution is not true for the agency. Okay, using these hypotheses, let's create a table of expected values for the different blood types. Let's go ahead and do it. We know the total number of people in the sample is 51, and 30% of those samples, 30% of that 51 should be type A. So, type O. So what's 30% of 51? Okay, that's 15.3. What else do we got there? We've got that 40% are meant to be type A. So what's 40% of 51? I think that's 20.4. Next, 20% are meant to be type B. So 20% of 51, that is 10.2. And lastly, 10% is meant to be type AB. So 10% is just 5.1. Do a real quick addition to make sure this works. And of course it does. Show that the conditions for the test that I identified in part A are satisfied. So remember that there are only 2 conditions that you have to worry about for any chi-square test. We've got the random sample condition, and then all expected counts need to be greater than 5. So do we have anything in the reading that tells us that this is a random sample? And I'm seeing right here, random sample of 51 artists. So we're going to quote that and put that in our work. For the next one, we have, we did our table of expected values. It's right above it there in our work. And then all we need to do is refer to the table because everything in our table is greater than 5. Now, heaven forbid, one year I had a student write C table, and they didn't write a table. So that's kind of bad news. Make sure that when you say C table, that you actually made a table of expected values. And I think to make this stronger, we could say C table of expected values. That's not going to hurt anybody, really. Letter C. Find the value of the test statistic and calculate the p-value for your test. Based on your work, what can you conclude about the proportions of blood types for this talent agency? So I'm thinking to be a little bit less confusing, I'm going to say that the test statistic is equal to sigma, the addition of all the observed values minus expected values, squared over the expected value. Now there's only 4 categories. It's pretty typical. So we're going to show all of the fractional pieces of our test statistic. starting with blood type O. Type O, we observed 18 in the random sample, and we expected to have 15.3. Type A, we observed 21 in the sample, and we expected to have 20.4. Type B, we expected 9. We observed 9, we expected 10.2. And for type AB, we observed 3 in the sample, and we expected 5.1. Now, just like before, we're going to grab our calculator, and we're going to do the actual work here on the calculator. So let's see. The quickest way to do this would be to put this into our lists. So let's get to our stat menu. We'll clear off our lists and start putting in our data. Okay, observed 18, 21, 9, and 3. Expected 15.3, 20.4, 10.2, and 5.1. And then at the home screen, we're going to do that exact same, I'm not even going to bother typing that out again. I'm just going to copy and paste that because it's the exact same thing. So the sum of observed minus expected squared over expected, that gives me 1.5. Okay, so my test statistic is equal to 1.5. Now the p-value then, the degree of freedom is the number of categories minus 1. We have 4 blood types minus 1. That tells me that the degree of freedom is 3. Now to the p-value. The p-value is the portion or the proportion under the chi-square curve that is greater than our test statistic. What was our test statistic? 1.5. And we'll go ahead and grab our calculator again, and we will get to the distribution menu, chi-square CDF. The lower bound is always your chi-square test statistic. Your degree of freedom here, that's going to be 4 minus 1. We'll paste that, and that gives us 0.6823. Now, they didn't give us a alpha level, but 0.68 is such a large p-value that it doesn't really matter what we use for our alpha. We were going to, we're not going to have evidence for our alternative hypothesis. So let's get to our standard conclusion. Let's see, the p-value is greater than alpha. So the data does not support the alternative hypothesis. And in this case, we should probably leave something. So what do we have? Our p-value was 68%. So 68% is greater than our normal 5%. And it does not support that. Let's copy and paste here. The expected blood type is not true. Okay. So now I know that the logic here can play tricks on you. We're saying that this distribution, this expected distribution is not true. Or we're saying that we don't support that the expected distribution is not true. Wow, so that's a lot of double negative talk here. You're going to have to kind of get through that. So again, let's kind of read through this one more time because I know it's confusing. The data does not support that the expected blood type distribution is not true, which means there's no evidence that the agency blood type distribution is different than usual. So hopefully you can get through that logic. I know it's kind of difficult with all the double negatives, but you really got to fight through that. So with that, that's the end of our question number 3. We'll see you later for more AP statistics. See you next time.